This lecture is going to be on significant figures. Now, I've always heard a major surgery is something that's happening to yourself, whereas a minor surgery is if it's happening to other people. That's not quite what significance means. Significant figures is a way that scientists express precision of a measurement. So for instance, let's say you're measuring something with a ruler and you've got centimeters here. And your nice pretty little ruler has little bitty tick marks for centimeters. Those are inches. We'll ignore those for now. But then you have other little bitty tick marks for millimeters. Why do they have all the different types of measurements? Because they want to express a measurement with different degrees of precision. If you're building a house and you're like, oh, approximately 8 inches, you'll be close enough. How square are those walls going to be? It would be like kind of my walls in my house where I'm like painting and going, that's not a 90-degree angle. Okay, so precision matters. You can express too much precision though, and that can also be negative. So let's say you're an ultra marathon runner. I'll never be an ultra, but let's say you're running and you're like, I need to run 48 miles. I don't know how many miles you're running. You're running a bunch, okay? If you're like 48 miles in one step, does that step really matter? Those 48 miles that you ran before, those 50 or whatever it is, those are the significant part. Or let's say I hop on the scale and then I weigh myself. And then I grab a dollar bill and I weigh myself again. Do you really think my mass just changed? My weight on the device is going to show the exact same thing because that extra dollar bill was not significant. And so significance is just how do I express myself as precisely as possible without overestimating with some confidence the wrong answer. Okay, so when you're doing a measurement, what you always want to do is let's say that our measurement should take place right here. And let's say this is 1, 2, 3, 4. So when you're writing down this measurement, you state what you know with certainty and then you estimate one more number. So in this case, you know it's at least 1 centimeter, so there would have been other tick marks here. Okay, but you know it's at least half, because 1.5. And then it looks like it's right between the 6th tick mark and the 5th tick mark. So I know it's at least 1.5, and it's probably closer to the 0.6 than it is the 0.5, so I'd say about 1.59 centimeters. And that would be the appropriate way to write down this measurement. If I wrote down 1.5 centimeters or 1.590, I have written down way too many or too few significant digits. Centimeters. Now notice everything has a number and a unit in order for it to be correct. Okay, so that's when we're talking about measurements. But significant figures also matter when you're looking at a number. How do I know in this number that every one of these is a significant digit? It's expressing precision. And so that's where you're going to see these significant figure rules that are going to matter so much in this class. So rule number 1 is if it is a non-zero number, it is always significant. So if it's a 5, a 7, a 9, a 4, a 3, always count that number as being significant. Rule number 2 says zeros, they're kind of wishy-washy. So let's look a little closer at these zeros. If it is a leading zero, so like 0.0035, these leading zeros are never significant. And the reason for that is if you wrote a number like 700, you could have put some extra zeros out front, but they didn't change the value or the significance of that number in the slightest. All right, captive zeros, that's numbers that are in the middle. So like 705, that 0 is in the middle of 7 and 5. So that 0 is considered a significant digit because it's in the middle, it's captive. All right, and then what about trailing zeros? So if we have 300 is my number. Are these zeros significant? It's going to depend on whether or not a decimal is present. If a decimal is present, then yes, they are significant. If there is no decimal present, then no, it is not significant. So in this case, 300, there is only one significant digit in that number. These zeros are both insignificant. So this only has one sig fig. Whereas if you have the same number and it's 300 with a decimal, then all of my trailing zeros are going to be significant, and this number now has 3 sig figs. Okay? It doesn't matter where in the number the decimal is. All that matters is there a decimal present? Then yes, the trailing zeros are significant. Or no, there's no decimal present, then therefore those trailing zeros are not significant. Alright, so then the last rule is if it is an exact number, then they are significant. And what that means is anytime you have a table, if you can look the number up in the trailer, we're going to assume that it's exact, and we're going to assume all of those numbers are significant. And so when we're making measurements and you're given a number, the first thing you have to do is figure out how many sig figs are represented in that number, and once you figured out which ones they are, then you'll be able to do some math with those problems.